All right, so today we're going to do some problem solving with using trigonometry. So here is our first question. It says each side of an isosceles triangle is 40 millimeters and the angle made by the two congruent sides is 100 degrees. Calculate both the altitude of this triangle and the length of the base of this triangle. So first of all, that would be a mistake here. An isosceles triangle only has two sides that are equal. So here in my triangle, like these two sides would be the equal sides. All right, so we should say that the two equal sides is what we should say here for that question. Okay, so the two equal sides of an isosceles triangle are 40 millimeters. So that means this here is 40 millimeters. So this here would also be 40 millimeters. All right, then it tells us that the angle made by the two congruent sides, so these are the two congruent sides, the angle made here is 100 degrees. Okay, so that's 100 degrees there. And now we have to calculate both the altitude of this triangle and the length of the base of this triangle. So basically, we are looking for the altitude. So I'm just going to go down like this. That would be the altitude of the triangle. So since we are splitting this in half, each side here, or each angle here, would be 50 degrees. So that would be 50 degrees, and that would be 50 degrees to give us a total of 100 degrees. So that's what our triangle looks like, and this here would be a right angle here. Therefore, this side here is also a right angle. Okay, so we have called x here the height, or the altitude. So let's solve for that first. So for that, we can use cosine because we're solving for adjacent, which is x, and we know the hypotenuse is 40 millimeters. So we'll use cosine of 50 degrees is equal to adjacent, which is x, divided by hypotenuse, which is 40. All right, to solve for x, let's assume that's 1. So x is equal to cosine 50 times 40. So cosine of 50, and then multiplying it by 40. All right, put that into your calculators and you will end up, I'm just going to round to the nearest tenth, 25.7 millimeters. Okay, so we have solved for x, that is the altitude or height. Next, we need to solve for y. So let's solve for y here. So solving for y, knowing we have 50 degrees here, therefore we're solving for opposite, and we know our hypotenuse. So opposite and hypotenuse, we would use sine. So sine 50 degrees is equal to opposite, which is y, hypotenuse is 40. All right, and then to solve for y, cross multiply, y is equal to sine 50 multiplied by 40, and we end up with 30.64, and it goes on. Okay, but just remember that's just for y here, which is only from here to here. We need to figure out the length of the base of this triangle, so we would have to double that to get it from here to here. So we'll multiply that by 2, and therefore our base is equal to 61.3. So I've just rounded to the nearest tenth. So 61.3 millimeters. Okay, our next example, number 6 from the module, calculate the altitude of a right triangle labeled MNO, where side MN is 15 centimeters angle N is 49 degrees and angle M is the 90-degree angle. Right, so the first thing we have to do here is draw our triangle correctly. Okay, so when we draw this out, so we have to pay attention to everything that's given to us here. So let's draw out a triangle. And we're told angle M is 90 degrees. So we'll call this M, and there's our 90 degrees. Next, we're trying to calculate the altitude of the right triangle. So this is what we don't know. We'll just call it X. Side MN is what we know, right? So this is the altitude. So therefore, side MN is 15 centimeters. So therefore, this would be O here. And then we're told angle N is 49 degrees. So 49 degrees would go there. All right, and this is what we're trying to find, is side OM, or we'll just call it X. All right, so for this case, we're looking for the altitude here, OM or MO, but I just called it X just to make it simpler here. So we have our angle here, 49 degrees. Opposite is what we're trying to find. Adjacent is what we are given. So we would use tangent. So setting this up, a tan 49 degrees is equal to X over 15. Okay, and next we're trying to solve for X. So that would be tan of 49, and we're going to multiply by 15. Okay, so put that into your calculators. 10, 49 times 15. And we're just going to round to the nearest tenth, so 17.3 centimeters. All right, that is the altitude of that triangle. All right, our next example, a person flying a kite has released 176 meters of string. The string makes an angle of 27 degrees with the ground. How high is the kite? And how far away is the kite horizontally? Answer to the nearest meter. All right, so we are looking for the height of the kite as well as how far away the kite is horizontally. So let's solve for height first. So here, okay, so we can use sine of 27 because opposite and hypotenuse. So we are trying to find x, we are given hypotenuse. So we can set it up as sine of 27 is equal to x over 176. Solving for x, cross multiplication, sine of 27 multiplied by 176. And we get 79.9. We'll just round that to 80 meters. All right, so that's our height. Next, how far away is the kite horizontally? So for that, we would use cosine. Adjacent is what we are trying to find. Hypotenuse is what we have. So cosine of 27 is equal to y over 176. And then cross multiplication, y is equal to cosine of 27 and multiply by 176, and we get 156.8. So we'll just round that to 157 meters. Okay, so those are the two sides that we were looking for. All right, so I'm going to pause here